Hi everyone, I'm extremely proud to demo our new free and open source DIY hardware wallet we have for LM-Bits. It's extremely cheap to build, only costs around £10. We have a lovely little 3D printed case for it as well. There's two more ways you can actually use the hardware wallet. You can either use it over web serial and send data to and from the computer via USB, just like a Trezor, or if you want, you can use it in an air-gapped way using the SD card slot on this LMPOS keypad face, which we have. I know a lot of you already have these microcontrollers from the Lightning point of sale, so it's nice that we can also make it into a hardware wallet. This is the LiDiGo T-Display microcontroller. It's got this lovely little screen on it. It's an ESP32 based board, so it has a hardware RNG module where we can generate our random number, which is really nice. So if we're building the wallet in the device, which you don't have to do, you can use dice or whatever you want to build your hardware wallet, your on-chain wallet with, but you can also build the on-chain wallet in the device, and you know that the entropy is pretty good for building your keys. So yeah, without further ado, let's put this thing together, let's get it flashed, and then let's start playing around with the software and hardware. So if you've got one of these little 3D printed cases and you want to put the thing together, then firstly put the little buttons in. There we go. And then put the USB side in first. Now I've used this a few times, so you should hear a little click when you put that together, but you know, I've done it a few times, so it's kind of come a little bit loose. And then also you'll have like 4 little legs on this back plate here. If we click that, but I've only got one left from putting it together and taking it apart again to demo. Okay, so we have our little buttons now there, and there's our little hardware wallet. It looks neat. Actually looks like a hardware wallet. It's quite impressive. If we plug this in, we can actually get it flashed. We're going to be using a web installer for this, so we no longer have to download all the Arduino ID and all that stuff. We can just install the software directly from the from this web installer, because this is an off-the-shelf device. It's just bought from a factory which is manufacturing in China from LiDiGo. And one of the benefits of that is there's no supply chain attack. So a big thing in hardware wallets is the company, the factory which are manufacturing those hardware wallets, they know they're going to be hardware wallets. Whereas with these, they don't know this is going to be a hardware wallet. They create gazillions of these things for all different purposes. Anyway, so we plug him in, and if we want to flash the software on via the web installer, just go to the latest version, click on flash. You'll see the device pop up here, connect to it. It'll say connecting, and then we want to install the LM-Bits hardware wallet, and then erase device, click next, install, preparing installation, and then it should say erasing, and then in a moment it should say installing, and it will take a few minutes to push the binary from the website, from our server, down the wire onto the actual device itself. While that's doing that, I'll take that time to show you where you can pick these things up. So here's our device which I'm using, which is a ESP32 based T-Display. At the moment they're on sale, so you can pick them up for £9. I did also see another link somewhere else for £8 to pick up one of these things. You can see also you can buy them with a case, which LiDiGo manufacture. Yeah, it's cheap, you know, £10, £12, something like that. You can get one. £12, you can even get one with a little case. So that's one place where you can buy them. Oh, I think maybe it's the 4 megabyte version is a little bit cheaper. You don't need all this memory because this is actually a relatively small program. So this you'll be able to get away with this 4 megabyte one. So there's one place to purchase them from if you want. However, if you want to support the project, you can also go to the LM-Bits shop. And if you go to LM-Bits hardware wallet in the shop, you'll see here that there's you can purchase the hardware wallet from us. It's a little bit more expensive, but then this is just your way of being able to support the project. So and you can also pick from a variety of all these lovely cases, different colored cases, which we can print out for you. So there's another place you can buy these things from. Has that finished installing? Yes, it has. You'll see it says unknown command on it. That's because once it's installed, the browser sends a bit of information to the hardware wallet, and then the hardware wallet says, I don't know what this bit of information is, hence the unknown command thing, because it's ready to receive commands. All that means is it's installed successfully, and now we don't need this site anymore, which you can get to, by the way, from lmbits.github.io and then hardware wallet, and then it will direct you to this installer page. And then on there also, there's a link to the GitHub, to the repo. There's a couple important notes here. this is a uBitcoin powered hardware wallet. So uBitcoin is the Arduino library which Step and Snigerev made for Spectre Wallet. So we're in good hands. All the Bitcoin stuff is, I mean, it's the original Bitcoin Core library, C libraries, which have then been minimized and made smaller for these little devices by Step and Snigerev. So it's a well-maintained and very respectable library, which we're using for our hardware wallet. There's also a link to the web installer, and then there's some more information down here, which we're going to have a look at for using the hardware wallet via the SD card. Right, so we don't need that either. We'll leave it open anyway. So once it's installed, we're going to want to connect to it with our on-chain wallet extension, and then wipe the device, generate a new on-chain wallet on the device. So just create your LMBits wallet as you usually do. I'm using the demo server. It's preferable if you use your own LMBits install. But actually for this use case, it's not so bad using the demo server, because you are just giving us your XPub. So all we can do is see how many funds you've got on your on-chain wallet. We can't actually spend any of those funds. So for some use cases, it'd be fine to use the demo server, I think. Right, so first we're going to want to connect to the device. When I first plug it in, I have 9 seconds or 10 seconds to connect the device to the browser. This is a security feature. So click on the device, click on paired, connect, and then we get this confirmation code. All data sent from the device to our computer is encrypted, and this confirmation code is just to show that the information is being sent and being decoded properly on the other side, or decrypted even on the other side. Once that's happened, you can't really see here. Let me change the color here. So there we go. You'll see that it's kind of orange. Now we need to, so it's connected to the device, but it's not logged in or anything. So now we need to wipe the device. I'm going to wipe it, and I'm going to give it a password. And I'll use this to log into the device when I plug it into my computer. Oh, QWERTY1234. There we are. QWERTY1234. Boom. Secure. Click wipe. It will say resetting, and then very quickly it will say successfully wiped. And then every new beginning comes from, what's that? Comes from some other beginning's end. I can't read. What it did just then, really quickly, is it wiped the memory of the device, and then it generated a new on-chain wallet, and then saved the seed in the memory of the device. So there's one security drawback. If you were to get this device, you would be able to take the seed and then steal your funds from this wallet. But in saying that, actually, the password is used to encrypt the seed, so they would then have to brute force the seed in order to be able to decrypt it. And also, if you use a passcode as well, then that would add some extra security to there. So it does have some security drawbacks, and it hasn't got that secure module, which something like a Ledger has. But it does have that random number generator, and you don't have that supply chain attack, and it's super cheap. And on the hardware wallet spectrum, it's better than putting your funds, managing your funds via a phone or something like that, or on a piece of software on your computer. It is an external signing device, which is nice. So anyway, so that's wiped. It's got a new wallet on there, and we're going to log into that wallet now. QWERTY1234. Here's where the option where you can add your passphrase, but I'm not going to do that. Now I'm logged into the device, which is nice. And when I'm logged in, first thing we're going to do, as always, with a hardware wallet is we're going to show that seed, and we're going to make a note of that seed just in case something happens to the hardware wallet. And from this seed, we can restore the on-chain wallet to this hardware wallet, or to another hardware wallet, such as a Trezor or whatever, what have you. In fact, what I'm going to do, because we're going to want to spend some funds, is I'm going to wipe the device again and show you the restore process. In case you have some funds saved on an on-chain wallet and you have a seed and you want to restore those funds. So I'm going to do that now. So I'm actually going to wipe it again. So I'm going to click on show seed. Not show seed, sorry. What we're talking about. I'm going to click on restore. And here we are. We can enter. So it says enter word 23. So in my case, that would be cupboard. And then I would enter that in, and there's cupboard. And then I click on next, and they say enter word 5. And then I can click on I can, find word 5 in my list, which is possible, and I can enter that, possible, and then next one, FOSS, next. So you can do it that way. However, for me, I find it easier just to write out the words in space separated in this input field here. So I'm just going to quickly do that. Right, so I've written that in, and then I put in the password which I used, which is the same password I used before. There we go. And then click on restore. And now, there we are, restore successful. So my seed was correct. I mean, it was a seed. Hopefully the words were in the right order. Now, hopefully if I bring in the XPub into our on-chain wallet extension, it should be able to read those addresses from the XPub and then find any funds which are in the wallet. So I'm going to click on add wallet account from hardware device. We can select whether we want to create a legacy XPub or SegWit or wrap SegWit or Taproot. I'm going to go for SegWit, and you can even change the derivation stuff if you want to. Add watch only account. Right, that's added. Now we need to scan the blockchain to see if there's any funds in there. When we're scanning the blockchain, we're using mempool.space. So you can point that to your own mempool.space if you're running your own LM-Bits install and be truly autonomous. Anyway, but we're using mempool.space for now. So we're going to click on scan blockchain. And there we are. We've scanned the blockchain. We can see there's a couple of wallets addresses here, which probably have funds in. So we have to give that a moment to find the funds for us. When you import an XPub into your on-chain wallet extension, there's the funds. There we are. So it found the funds. That's great. So the restore process from my seed worked. We'll see here that we also get, I think that's the first address from the XPub as well. So if you want, you could verify that against the first address here. So we found our funds. And every XPub you import, if you click on this little plus thing, you'll be able to make a copy of that XPub. You can create a QR code of it. You can delete it. You can generate new receive addresses if you want to, and you'll just add it to your little list down here of receive addresses. So you can have a fresh address for every transaction, which is good for privacy. That's how, the point of XPubs. Also, if you have the on-chain wallet extension enabled and it has an XPub in it, then other extensions in your LM-Bits can make use of on-chain then. So the SatsPay extension, for example, can then generate on-chain addresses for you to send funds to, which is pretty nice. So, and when you generate those new addresses, they'll show on the device as well. And then if we click on one of those addresses, then we'll be able to see that address in mempool.space, which is very nice. Now, so we have some funds in here. So now I'm going to send some funds and create a payment. And the way I'm going to do that is I'm actually going to go buy one of these LM-Bits hardware wallets from the shop.lmbits.com. So I'm going to select a color. I'm going to go for pink, I think. Add to cart, and then view cart. And yep. All looks good. Proceed to checkout, please. And input your credentials. It's remembered me from the last time I inputted my credentials here. We're paying with Bitcoin, and this is using, so this is a WooCommerce site, and we're using the LM-Bits SatsPay extension as our payment gateway, which is pretty nice. And then I'm probably going to blur out here, click on place order. Right, then it generates a Lightning address for us to send funds to, but we don't want to use the Lightning address, we want to use the on-chain address. So here's our address. We're going to click on copy address. I'm going to go to new payment. I'm going to put the address in there. Then I'm going to go to the amount, which is this amount here. And I'm going to put the amount in. I really like the UI which Vlad Stan has made for the LM-Bits on-chain wallet extension. I think it's he worked on Bitcoin.js before coming and working on this with LM-Bits, and you can really tell that from his work here. It's so slick and minimalist and simple, but if you want, you have more complex on-chain features, such as batch transactions. I can add a bunch of extra addresses and amounts there, and we can do a batch transaction. Save on those fees. We can also all these are kind of automated, such as fees, coin selection, and change addresses and things. But if we want, we can tweak them and change them. So we can, you know, if we're willing to wait a little bit longer, we can turn our fee down, or we can turn it up if we want to get this transaction through quickly. If you click on refresh fee rates, oh, look at that. I think the mempool's very busy at the moment. If you click on refresh fee rates, it goes and gets the latest fee from mempool.space. Oh, in fact, it's not actually refreshing it there. Look at that. That's something. There we are. There's an issue to put on the repo that it's not refreshing it. Well, I'm going to set my own fee rate. I'm going to set it to 5,000 sats. Actually, I want this transaction to go through, so I'm just going to whack it all the way up to 35 sats per byte. Probably heavily overpaying right there. And then if you want to, you can do coin selection as well. So you can select what coins that you want to spend. Currently, I only have 1 UTXO to spend out here. So yeah, so I'm just selecting that. You can also change the change address if you want to. Currently, it just goes and grabs a change address from this XPub. So once that's done, if you just click on check and send, it will generate the PSBT, send it to the signing device, and then we'll see the amount which is being sent. Click next. Oh, these are our different outputs, yeah. And then click next, and then it says the fee, confirm, and then you need to press a button on the actual device itself to confirm, to actually sign the PSBT. It signs it, then sends it back down the wire, and here is our partially signed Bitcoin transaction with some details about that. And then if we want to broadcast that, we just click on send, and that transaction is broadcast. And if we click on scan blockchain, it should update our balances on the on-chain wallet extension. And then if we then go to this address, if I click on here, yeah, it takes me to mempool.space too. Here we are. We can see the transaction, that it's unconfirmed. So we want to wait for that transaction to confirm. When you're buying something from shop.lmbits, if you're paying on-chain, then leave the browser window open until the on-chain transaction has settled, or go and open this window up again once it's settled, because this is the thing which then sends the webhook back to the site, to the shop, to say that yes, this order has been paid for, please send it to the customer. So make sure you leave that open, okay? So I'm going to go make a cup of tea and then come back, and hopefully that transaction has cleared. So our order has been placed. We can go back to the shop, and we can see our order details here, and we can sit and wait for our lovely new hardware wallet to come from LMBits, which is nice. Now I want to show you how we can use this hardware wallet in an air-gapped way, because I think that's really interesting for people who aren't happy plugging this device in and then using web serial. I think the web serial thing is fine for a limited amount of funds, but I think maybe the air-gapped thing might be better for, you know, more funds. So I'm going to unplug this. I'm actually going to stay on this page for managing my on-chain funds. I'm just going to add a new XPub to here. So as before, where can I get to? Oh, look, here we go. So we have a Flash binary directory from browser, so I can click on that here, and that'll open up that web installer for me, which is nice. I will need to, I think, refresh that to disconnect the web serial from it. Then go to the latest version, Flash. And just as before, we're going to flash this device with the software. Erase device. Here we go. We're going to have to power on the software while we power on the hardware wallet while we're using it. I would advise using an external USB power bank, or to power it, or you can use one of those USB wires which hasn't got the data line in it, so you know there's no communication happening, you know, between your computer and the device. If you go to the repo, there's details on the different commands and stuff which we can send via the SD card. This is a truly incredible project, and a huge props and hats off to Vlad Stan, who's the developer of the hardware wallet. If we go to run from SD card, and we go to examples on the SD card, and if I go to ext01, then let me check the other one actually. Oh, 2 months ago. Okay. Then we'll see we've got 3 files here in the, let's go back, here we go. So it gives us instructions. So first we mount the SD card to a computer, then we create a file called commands.in.txt. So we'll do that now. And then once you've done that, then you can go to the examples and start adding examples. So all our commands and things are going to be sent via this SD card. So in this SD card commands.in.txt, we're going to want to, let's go to these examples. Here we go. Pair false. So if pair is set to false, then this will be used in kind of like a stateless way. It won't save the seed on the device. You'll have to keep the seed on the SD card. I want it to be the seed to be saved on the actual device itself. So I'm going to set pair to true. And then if you want to restore, you can, like before, if you've got a wallet you want to restore to the device, then you can restore this way. I don't want to restore. I want to wipe. There's not a wipe example there. Let's go to the other set of examples and see if there's wipe in here. No. So I'm just going to wing it, right? And I'm just going to say, where are we? Here we go. So I'm going to say I want it to be paired. So I want it to save any seed it makes. And then I want to wipe it, save, and then I'll make sure that this is documented actually in the hardware wallet. I'm just using logic here to figure out how to wipe this thing and set a password. So SD card. Resetting, okay, so it's wiping it. Successfully wiped. I think that worked. I think it wiped, and I think we managed to set that as a password. Let's see. So now, on our little SD card, we should have... Let's have a look. Yeah, we've got a bunch of other files now. So now we've got commands out. So it says basically the wipe was successful, yeah? And then if we go to the log, then this is all the stuff which was logged out, yeah? Right, so let's try logging into the thing. So now this is password. So we have got, keep that pair thing to true. Password QWERTY. So the seed is now saved on there. So if I power it off and power it on again, the seed is saved there. So I'll leave that password true, and then I want a xpub. Here we go. I think we need more examples in here. Right. Mainnet. And there's our derivation. It will default to segwit. Save that. So now, fingers crossed, we should be able to, when it powers off, when it powers on again, it should log in and then create an xpub and then send the xpub to commands out. Let's have a look. Cross our fingers. Okay, password correct. Yay, that totally worked. Nice. And then we have that first address there generated by the xpub. That's super cool. Right, so now we can take that out, plug it back into our computer. This is going very well, considering I haven't got all the commands. That's not right, is it? Let's close that and open it again. I think it's there we go. So yeah, password worked. So the one just means yeah, that worked. The password worked, and yes, it generated an xpub, and yes, here is my xpub right here. So now I can copy this xpub. And I can bring it into my on-chain wallet extension. Let's close this. New account, pop that in there, and then what should we call this? Air gapped. Oh, right, yeah. On the end there, you'll get these integers. Just delete those and the space. There we go. And we're in. Okay, cool. So here's my air gapped wallet, and I can create addresses, derive addresses for it. That's pretty cool. All right, so what else can we do? We can password clear, address, or you can get an address and then tell it where you want, which address you want to be derived on there. That's pretty cool. Let's have a look at the other examples. Restore. Where's the... on here now. No. We want the show seed, don't we? We want the show seed command. And I don't know what the show seed command is. Again, if we go back here, though, it's kind of like fairly obvious what these commands are. Seed. Here we go. So it's seed. Let's see if this works. Let's see if we can show seed and make a backup of our seed. So commands in is we're going to keep the password there so it logs in, and then we're going to say, what was it? Seed. So it should log in, get the seed, and then stick it in this commands.out thing. So save that, take the SD card out, pop it back in our air-gapped hardware wallet, unplug it, plug it in again. So it should log in, and then password correct, show seed done. This is working so well. I'll make sure that we get those extra examples, like the ones we haven't documented, which I'm doing right now, in the repo for you lot. Reload. Here we go. There we are, and there's my seed. Sweet. One last thing I want to quickly show you is how to do an on-chain transaction and make a payment from the air-gapped hardware wallet, because obviously we can't send the PSBT over the wire. So add your Bitcoin address, amount, whatever, or your custom settings, or just leave them as they are. And then instead of clicking on check and send, click on the little drop down arrow, then go to share PSBT. This will give you the partially signed Bitcoin transaction. Now this won't work because we don't have any funds on this on-chain wallet, of course. But I'm just going to copy this, and then in your commands.in file on the SD card, and if you've put the password in, do PSBT and then mainnet, and then put the PSBT in, sign it, save it, pop the SD card out, okay, pop it back in there, unplug, plug it in, and then you'll see that it signs in using the password, and then it'll attempt to sign the PSBT, which will just fail at because obviously we don't have on-chain funds, we've got no UTXOs. Pop that out, pop it back in, open up commands out, and then your signed PSBT, if you have UTXOs, will be bigger than this, and then copy that, go back here, click on back, click on this little drop down arrow, click on from signed PSBT, and that's where you put your signed PSBT and broadcast it. But obviously we can't do that because it's not a legit PSBT with UTXOs. But that's how you do the on-chain payment from the hardware wallet when it's air-gapped. And there we go. We have a very cheap, easy to make, DIY, free and open source hardware wallet with no supply chain attack. Only costs £10. You can use it over web serial, or if you want, you can use it in an air-gapped way. You can use it stateless, or you can save the seed in the device. So very diverse hardware wallet project, which can be used in a bunch of different ways. You can also extend the code, and if you do, and you find, you have some functionality which you find other people might find useful, then please do PR the project. Like, it's free and open source, and contributors are very, very welcome. And a big note, which I haven't mentioned so far, is on the hardware wallet site, it does mention just use this for testnet funds, don't use it for mainnet funds. So Vlad, who's made the project, he doesn't want people to be using mainnet because he doesn't want anyone to lose any funds, and it's still in beta. So do be very careful, unless you're being a little bit reckless like me, and then I use it for managing small amounts of on-chain funds on mainnet. What I really like as a combination of functionality from LM Bits and this sort of hardware is you can say to a cafe, your local cafe you want to onboard, you can create a software point of sale, such as this one here, where they can accept lightning payments for drinks and stuff. And then those payments accumulate in this wallet. And then you just say to Bolt Stock Exchange extension, you say, well, every time we get 300, 400,000 Satoshis in this wallet, loop out to on-chain. And then you could just give your local cafe one of these hardware wallets and say, right, your risk profile is 100 quid. People are going to come in, they can now pay for drinks with Bitcoin over Lightning. I will host this service for you, but every £100, it's going to loop out and it's going to send the funds to on-chain to this hardware wallet where you can accumulate those funds. I think generally cafes and bars who want to accept Bitcoin, where you don't have a circular economy where they can spend that Bitcoin, they just want to use it as a way of accumulating Bitcoin, and that's fine. And I think this kind of caters for that need. They're not going to store those funds forever on your LM-Bits install, and they're not just going to take those Lightning funds and put them on a wallet as Toshi. They're going to be looped out to on-chain and put in cold storage, which is exactly where they should be. So I think that's a really nice collection of functionality which you can just take to your local cafe. And they have a risk, which is £100 for them to accept Bitcoin. You may run off with that 100 quid at some point, or your server may get hacked. I don't know, whatever. But that's all their risk. You can sell it to less. You can sell it to 50 quid. That's all their risk is for outsourcing. Running the software, and then their funds just accumulate in the hardware wallet. Anyway, I think that's a really nice use case for the hardware wallet. If you find more use cases, please, drop in an issue on the repo. If you find any issues, you obviously put them in the repo, and then PR's contributions very welcome. Have fun playing around with it. Have fun building it. Any problems, reach out to me or reach out to Vladstan. Thanks so much for watching, and I'll see you again. Cheers. Bye.